minus 7x and all that?
So it goes down by a degree of 1. It was x cubed in the first column, now it's x squared. It was x squared, now it's x. It was x power of 1, now it's a constant.
Oh, I see. Okay. And then would I just distribute that?
Nope, that would be going
Oh,
backwards.
factor.
You got to factor it. Two numbers that multiply to 12 but add to -7.
Okay. 3 and 4.
Yeah, so x minus 3, x minus 4.
Okay, that makes sense. And then that would be my answer.
Well, that's factored form.
Mm-hmm.
So the question actually doesn't really say, but it says to factor completely. This is factored form. Like usually you do something with factored form, but they're not scheme for that here. All right, number 2 is very much the same. So you have to first figure out the number that goes in the box. You do that by setting 2x minus 1 equal to 0. Could you solve that and tell me what that is for x?
So 1/2. Right?
Yes. Okay, and so the coefficients 4, -6, 8, and -2. All right, so we're going to bring the 4 down. 4 times 1/2 is 2. -4 times 1/2 is -2. You add, you get 6. 6 times 1/2 is 3. This last number is always the remainder.
Oh, okay. Yeah.
All right. Any questions on that?
No, that makes sense.
Okay. All right, so the next question here is to graph. So an x-intercept means that it crosses or touches at that value. So you want to put a dot there, like at -5, -1, 1, and 3. And there's actually a lot of options from here. Like this is actually a pretty nice problem. Like you can do a lot of things. You either have to start high and end high, or start low and end low. Does that at all sound familiar?
Yeah.
Okay. So it's up to you. Let's just say you started low, you'd go up and come down, something like that. Oops. I'll do the other one. I mean, if you preferred the other one, you just start high, come down, you know, something like that. That's it.
Oh, okay.
Okay, so before we can do 4 and 5, there's 4 graphs that you have to. Uh, that's weird. Oh, I don't know why it's telling me this. Cannot upload your changes. Just a moment here. I don't understand why this is happening right now in the middle of the lesson. Oh. All right. All right. So we'll be back here. Why are they giving me this message again? All right, I don't know. We'll get back on the lesson though. So the next questions, there's four graphs that you need to know.
Mhm.
And it depends on the degree. So if the degree is odd and the leading coefficient is positive, the degree is odd and the leading coefficient is negative, starts low, ends high, starts high, ends low. These are two of the four graphs that you need to know. Now, in terms of the end behavior, as x goes to infinity, so this is talking about the right here. This is rising. So you say f of x goes to infinity as well. Is that something you've seen before?
Yeah.
As x goes to negative infinity, f of x goes to negative infinity. That's falling. That's on the left here. All right. So
Mhm.
now on the next one here, it's kind of the same thing, but it's different directions. As x goes to infinity on the right, f of x is going to negative infinity. As x goes to negative infinity, f of x is going to positive infinity. And then there's two more graphs to know for even degree positive leading coefficient, even degree negative leading coefficient. And so there's like two more graphs to know for these. I'm running out of room here, so let me put this down here. As x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to infinity. And then this last one, as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to negative infinity. So you're responsible for knowing these four graphs, because to do the next couple of problems, you have to know the degree and the leading coefficient. All right, so I'm going to grab question 4. Uh, so the degree here is what?
3.
It is 3. And how about the leading coefficient?
Would that be 3 as well?
It's the number in front.
So, okay.
All right, so which of these four graphs is it? Well, it's one of the odd ones. It's got a negative leading coefficient, so it's this one. So really what you want to be able to do with this is draw the arrows and then uh and then you can do the end behavior. So once you have the graph, it's easy to say, okay, as x goes to the right forever, that's the one over here on the right. It's falling, so that goes to negative infinity. As x goes to the left forever, f of x is rising.
Okay.
So really, you've got to extract the degree, the leading coefficient. The leading coefficient's the number in front of the biggest exponent.
Mhm.
They're not always in order. Like sometimes they sneak them into the end, be deceptive.
Okay, that makes sense.
All right, so for number 5, same thing here. You have to be able to identify the degree and the leading coefficient. What is the degree of this?
The degree is 4 and the leading is 8.
So positive, you could say, and this one's even. The graph is up and up. And then you can compare it back to, which one is it? Well, it's this one here. So as x goes to infinity, that's to the right forever. F of x also goes to infinity. As x goes to negative infinity, f of x goes to infinity.
Okay. Got that.
All right, so let's take care of page 1. Where do you want us to go from here?
Um, we can do 6 and 7 next.
Okay. All right. The x-intercepts are where it crosses the x-axis or touches. There are 3 of them. Can you tell me just the x values of those?
Mm-hmm. Um, it would be, oh, I can't really tell. Is that like a 2 on the x axis? So would
They're
that
they're
make
give
that like
they're they're give
1.5?
they're giving you the ordered, like they're pointing at them.
Oh, okay. So then,
You don't have to do no effort here doing that.
so 0.55 and 2.26 and 0.853.
Just the ones in red are where it crosses the x-axis.
Oh, oops. 0.853 and 3.197.
Yeah. Okay, so the relative max, if you ever been hiking, it's like, where's the biggest point kind of compared to
Mhm,
everything else? That's the one in blue there.
mhm,
So there's 2 things. There's like, what is the max? Well, never mind. I guess this is not written well, but they usually ask 2 questions. Usually ask like, what is it and where is it? The relative max is 7.407. Okay, they're asking for the y value. Now the max, they're really asking like the absolute max. Since this goes up forever, that does not exist. At least the way that traditional textbooks would answer this.
Let's see.
Now the relative min, that's this point here. It's the y value again. It's -3. Like it's lower than everything else around it. All right. Now the min does not exist because this goes down forever. Goes down forever.
Mhm,
There is no min. Okay, so end behaviors, x goes to infinity as it goes to the right forever. So as you go to the right, is the graph rising or falling?
Falling.
It's falling, that's negative infinity. Going the other direction,
So it's just positive infinity.
yeah, it's called rising. All right, so I'm going to highlight where it's increasing
Mhm.
in this yellow here. You want the x values. For increasing and decreasing, it's only the x values that you care about. What are the x values?
Um, would it be 0 and 2.26?
Good. Decreasing, I'll highlight here in a different color.
Um, would it be like infinity to 0 or?
Yeah. So it's the x values again. And then 2.26 to infinity.
Alright, that makes more sense.
All right. Any questions on that?
No, seems pretty good.
Okay, so 7 is very, very similar. Like you to make an effort here to see what you can answer. We'll just do the same thing here again. I'll ask you, give me the x-intercepts.
Uh-huh. -2.334, -0.742, and +0.742, and +2.334.
This one has 1 relative max and 2 relative mins.
Um, oh, okay. So the relative max would be
We want
mm,
the y value there.
um, 3.
Yeah, very good.
And then
Does it have an absolute, it's considered an absolute max
it does not have one.
because it goes up forever. Yeah. How about a relative min?
That would be -6.
Okay. Now this one does have a absolute min. It's the same place.
Okay, makes sense. And then would it be um positive infinity and then um, positive again?
Yep, they're both rising. Okay, increasing, decreasing. So I didn't say this in the last problem, but it's increasing when it's going up and to the right.
Or-
It's decreasing when it's going down and to the right. So
So the
there's where it's increasing.
so the increase would be it's the
It's
x
always,
value, right?
it's always the, yeah, exactly. Very, very important to remember that.
So it would be -1.732, comma 0,
Okay.
and then decreasing
But
0.
yeah, so I would get both increasing.
Oh, okay.
And you're right. There is a decrease from 0 to 1.732. That's for sure. But there's 2 intervals where it's decreasing to or it's increasing.
And then other increases 1.732 to infinity.
Good.
And then the last decreasing, or there's only, oh wait, no. There's, oh wait, yeah, that's it, right?
There's 2 intervals where it's decreasing. You've only given me one of them. You've given me this one in green.
Would it be infinity to -1.732?
Negative infinity.
Oh yeah, negative infinity.
All right, good. All right, I think you said you're good on 8 and 9. Perform the indicated operation.
We could do 13 and 14 because that's division.
All right, does it say that you have to use long division or can it be synthetic?
It kind of just like depends on the problem, I think, but we learned both. I just wasn't there when we learned like the division, so I just need a little bit more help on that.
Do you want me to do long division or synthetic division on this?
Um, Maybe one synthetic and the one long, just so I could see how it works.
All right, so the long division here, you put x minus 5 on the outside. 2x cubed minus 11x squared plus 13x minus 44 on the inside. You're trying to figure out what do you multiply x by to get 2x cubed? And if that's unclear, you take 2x cubed and divide it by x to get the answer, which is 2x squared. And that goes up here in what's called the quotient.
Mhm.
And you take your quotient and you multiply it by this out in front. So you're going to take 2x squared and multiply it by x. That's 2x cubed minus 10x squared. And then this is very important. You change the signs. You are subtracting, but I found it's better to show it as change the signs. And then
Mhm.
you add negative 1x squared. You bring this down. And then you repeat. It's like, what do you multiply x by to get negative 1x squared? And if you're not sure, you come off to the side and you divide. So you can see that's negative 1x. And so now you take this negative 1x and multiply by each of these. So you get negative 1x squared, and we multiply by x plus 5x. And then you again change the signs. Very important to change the signs each time. The first one should always cancel.
Mhm.
This is 8x minus 44. And then same thing, you have to say, what do you multiply x by to get 8x? And if you're not sure, you take the 8x and divide it by x. So then you multiply here, 8 times x is 8x minus 40. You again change the signs. And whatever is left over, in this case negative 4, this is your remainder. Sometimes that's useful, depending on the problem.
Okay, that makes a lot more sense.
Okay. You want to try 14 on your own? Ask me some questions.
Yeah,
Uh,
I'm sure that one.
Sorry, this one's got a little wrinkle to it. Let me jump in here real quick. You have to make sure you include all of the degrees.
Mhm.
And so this one's missing x cubed. So you have to include that with a 0 in front.
Could you show me the first um the first calculation?
Yeah, so you're trying to get to x to the fourth
Mhm.
and from x. So you take x to the fourth and divide it by x, which is x cubed, and that goes in the x cubed column. So
Oh,
then you
okay.
take that x cubed and multiply by x and minus 3x. So it always has to match up with the
Oh, I see.
one there. So maybe take it from here.
Yeah. Okay, I'm a little lost. I don't really know what to do.
So what you maybe you haven't noticed is you're always taking this leading one here,
Mhm.
3x cubed, and you divide it by whatever is in front, which is the same each time. You get 3x squared, and that's what goes up here at
Uh,
the top. So then you take 3x squared and you multiply it by x. So that's 3x cubed minus 9x squared. And so now, again, the leading one should always cancel out. So now it's negative 1x squared, bring the 2x down. So you always look to the leading one here. So it's minus 1x squared divided by x, which becomes minus 1x. And then that goes up here at the top. So could you try multiplying minus 1x by x and minus 3 and seeing what you come up with?
yeah. Okay, I got negative 1x squared minus 3x.
Plus 3x, because you've got a negative 1
Oh,
times a negative 3.
yes.
And then you change the sign, so you get minus 1x and bring the plus 3 down. And then same thing again, kind of rinse and repeat again. You get negative 1, that goes back up here. Sorry for all the scrolling. -1 times x, -1 times -3. You get -1x plus 3, change the signs, and this time you get a remainder of 0.
Oh, okay.
Doesn't always work out like that, but this one did.
Mhm.
Yeah, and these are way easier with synthetic division,
Yeah.
but sometimes they say thou shall use,
Mhm. Yeah.
polynomial division, long division, so you must do it that way. All right. You want it to move into a new direction here? What else? What else can we do?
We can see. We can do uh just 26, and I think I got the rest.
Okay. So list all the possible roots. Does that look right to you?
Yes.
All right. So there's this uh, rational root theorem or something. It's got a name. I think that's what it's called. But they label the last number p and the first coefficient q, and you have to first start by listing all the factors of
Mhm.
each. So the factors of 18 are 1, 2, 3, 6, 9, and 18. These all divide evenly into 18. The factors of 3 are 1 and 3.
Mhm.
Is that okay so far? It's a recipe. It's like you always follow these steps.
Mhm.
All right, so then you take each factor of p and you
Mhm.
divide it by each factor of q. So it looks like this: plus or minus 1 over 1, plus or
Mhm.
minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, plus or minus 9 over 1, plus or minus 18 over 1. So I took every single factor from p and divided it by 1.
Mhm.
Now I'm going to take every single factor of p and divide it by 3. So you have plus or minus 1/3, plus or minus 2/3, plus or minus 3/3, plus or minus 6/3, plus or minus 9/3, plus or minus 18/3. And then you grab the ones that are unique. Okay. So like, for example, 3 over 3 is really 1. So that one we don't need. 6 over 3 is 2. We don't really need that one because we have 2 in the top list. 9 over 3 is 3. We already have that one. 18 over 3 is 6. We already have that one. So you just list them all. Um, and then you do simplify. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18, like that.
Okay, I got that. Okay, well, I think I get it now.
Right. We have some time left. You could do some more division, long division problems, other things. Is there anything else you would like help with tonight?
Um, we could. I think I got it, honestly.
Are you sure? I'll just
Yeah,
ask one more time. All right. Well, we
yeah.
can absolutely stop there for